Hey guys, today I'm going to show you how to solve monohybrid crosses. So we're going to review these 4 problems that I want you to record in your notes. Number 1 says, in rebops, curly tails are dominant over straight tails. Cross a homozygous dominant and a homozygous recessive rebop. So when you're setting up your Punnett squares, the first thing you want to do is you want to figure out the parents. It tells you here that curly tails, I always underline the dominant and the recessive trait so that I can keep straight. Oh, curly tails is capital T and straight tails is lowercase t, and the letter doesn't really matter, but I'm going to go ahead and use the letters that were given to me. It says cross a homozygous dominant. So homozygous means the alleles will be the same, so the letters will be the same, and dominant means I'm going to use 2 capital letters for that parent. I'm going to cross that with your homozygous recessive rebop. So for my homozygous, once again, that means same, and then recessive means I'm going to use the lowercase. So on the other side, one parent goes across the top, other parent goes along the side, and it doesn't actually matter if you cross them and if you put this parent on this side and this one on this one, and I'll show you that on the other problem. So then all I do is I take the top one and the side one and I cross them into the box, putting the dominant allele first. So I'm going to put the capital T first and the lowercase t second. I'm going to put the capital T first and then the lowercase into this box, capital T here, lowercase in there, and then I cross these 2 into this box. So as you can see, when I cross a homozygous dominant and a recessive parent, I get 100% of the same thing. So my parent genotypes are out here, and then the phenotypes are, this one's going to be curly tail, this one's going to be straight tail, but I get 100% heterozygous. Or another way to think of that would be 100% curly tails. So they would all have, all of their offspring will have curly tails. So you would just have to watch out for what question is being asked, how many have curly tails, or what percentage, or maybe they're going to ask you how many will have straight tails, and in that case, 0 would have straight tails, okay? Number two says, in rebops, red nose is dominant over green nose. Cross a homozygous recessive and a heterozygous red nose rebop. So once again, first thing I need to do is I'm going to find the parent. And again, it doesn't matter if one parent's here and the other one's there, or you flip them. It doesn't matter. The red nose is a capital N and the green nose is a lowercase n. I'm going to cross a homozygous recessive, which means I'm going to have a little n because it's homozygous, which means same, and then recessive is my lowercase, my recessive allele, and a heterozygous red nose, which means heterozygous means different. So I have 2 different alleles, and it's going to be red nose, so it's going to be capital N, lowercase n. I'm going to write that in right there. Once again, I'm going to cross this side with this one into this box, capital N first, lowercase n second. Cross this one and this one into this box, capital N, lowercase n. And then into this one, it's going to be 2 lowercase n's. And here, it's going to be 2 lowercase n's. All right, so then I've got to be prepared to answer questions. For example, if I asked you, what is the probability of having a red nose rebop? Well, these 2 right here, you have 2 out of 4 shots of having a, oh, I said that incorrectly, actually. No, I'm right. You have 2 out of 4 shot of having these 2 as red nose. And then you have a 2 in 4 shot of having a green nose. So up here, I wrote it as a percent. When I said they were all heterozygous and they all have curly tails, I said 100% of them have that. I could have also said 4 out of 4, depending on what I was asking. On this one, I could also say 2 out of 4 have a red nose, and then 2 out of 4 have a green nose. Or I could say, it would be the same thing if I said 50% have a red nose, or 50% have a green nose. It just depends on what the question is asking, okay? I could also ask you questions about the offspring. I could ask you how many will be heterozygous, and you would, in that case, you would look and you would say, oh, 1, 2, 2 out of 4 would be heterozygous. So when solving these problems, most of the time, you guys can solve them fairly easily. the struggle is to figure out how to interpret them and what the question is actually asking you. All right, so number 3. In rebops, red nose is dominant over green nose. Cross 2 heterozygous red nose rebops. So red nose is dominant, green nose is recessive. And they want me to cross 2 heterozygous parents. So one parent up here, I write one allele over here, one over there, and then another heterozygous parent right here. I'm gonna cross this one and this one into here. I'm gonna cross this one and this one into here. I'm gonna cross this one and this one into there, and then this one and this one into here, okay? The outcome's a little bit different this time. I get 1 offspring that is homozygous dominant, I get 2 offsprings that are heterozygous, and I get 1 offspring that is homozygous recessive. Whenever you cross 2 heterozygous parents, it's when you're gonna get the most variety within this. So when looking at the Punnett square, this guy is going to have a red nose. These 2 are gonna have a red nose. So you have a 3 and 4 shot of having a red nose, or that would also be known as 75% red, okay? Because each quadrant, if I haven't said that, this is 25%, 2 of them would be 50, 3 of them would be 75, and then completely filled would be 100%. And then you have a 1 in 4 shot of having a green nose, okay? Or 25% shot of having a green nose. So again, when these 2 parents mate, this is the probability of their offspring, and that's what we're predicting right here, okay? Last one, number 4. In rebops, having 2 eyes is dominant over 1 eye. Cross a homozygous dominant 2-eyed and a heterozygous 2-eyed rebop. You have 2 eyes, that's dominant, capital E, and you have 1 eye that is recessive, okay? Cross a homozygous dominant. So homozygous dominant, homozygous means the letters are gonna be the same, 2 same alleles, and dominant means they're gonna be capital letters. So here they are, capital E, let me draw my Punnett square, and it wants you to cross it with a heterozygous 2-eyed. So he's gonna be capital E, lowercase e, okay? You're gonna cross them. Pretty easy part right there. And then all you have left to do is you have to interpret what's in there. We have 2 of them that are the same, and then these 2 are the same. These 2, since they're carrying the dominant allele, are gonna have 2 eyes. So you have a 50% chance of having a 2-eyed creature. And you have a, no, I'm lying. These 2 also, even though they're carrying the recessive allele, it's not a 50% 2-eyed, it's 100%. Okay, these 2 would also have 2 eyes, because the only way you're going to get a 1-eyed creature is if you have 2 of the lowercase alleles that show up, and since this is 100% 2-eyed, you would have 0% 1-eyed. Okay, the other questions I could ask you, things like how many of the offspring would be homozygous dominant? You would tell me 2. These 2 are homozygous dominant, and these 2 are heterozygous. So again, be really careful. Punnett squares are pretty simple to solve when you're working with just one trait, but it's always about what was the actual question. Did she ask me about how many had 2 eyes, or did she ask me how many had 1-eyed, or maybe she asked me how many are homozygous recessive? So be sure that you pay close attention to what the question is actually asking.